So with adding and subtracting radicals, like I said, it's really important that you guys know how to simplify your radicals, because you can't add and subtract unless they are in simplest form, because you have to be able to find what's called common terms or like terms. So it's no different than if we were to add and subtract variables together. If we've got 3x plus 7x, we know that that's going to equal 10x because of the fact that they have identical variables, right? They are like termed because their variable is the same. So all that they wind up doing is taking that coefficient and adding that together to equal the 10, and then the variable stays just as it is, right? Nothing changes with those x's. It's no different if you're doing this with radicals. With like radicals, you have a common radicand. So remember, the radicand is that value, whether it's a number or an algebraic value, inside of the root. So inside of the radical symbol. So for example, 2 square root of 5, or 2 radical 5, plus 4 square root of 5 is going to equal 6 square root of 5. That 5, that square root of 5, those happen to be the like terms. So it stays square root of 5, and you're just focusing on adding your coefficients together. So 2 plus 4 gives us that 6. We keep the square root of 5 as it is. Okay, and I'll even write that down. Square root of 5 is the like term. We're just going to add the coefficients. That's all we did. We added the coefficients. We kept square root of 5 as it was. So with that knowledge, what I want you guys to do right now is do just problems 1 and 2. Just focus on problems 1 and 2. Shouldn't take you too long. All right, so 3 square root of 7 plus 8 square root of 7, what is that going to give to us? 11 square root of 7. Good. We're just going to focus on the 3 plus the 8. 3 plus 8 is going to provide us that 11, and then that square root of 7, those happen to be the like terms, so it stays square root of 7. Okay? What about number 2, 9 square root of y minus the square root of y? What is that going to give us? 8 square root of y. Very good, because, yeah, we've got this 9 here, but we don't have anything written in front of it, but whenever we don't have something written, we automatically know there's an imaginary 1. So we're really focusing on just doing 9 minus the 1, which is going to come out to that 8, and then that square root of y is going to stay the same. So those are easy because they already have them written in like terms. But not all of them are always going to be written in like terms. Sometimes you might have to simplify them, or you might not even be able to simplify it at all. So for example, number 3, 12 square root of 2 minus 4 square root of 11. The square root of 2 and square root of 11 are not the same. So the first thing you need to ask yourselves is, can you factor square root of 2 or square root of 11? Can you factor out square root of 2? No, because the only factors are 1 and 2, right? So that's as simplified as it gets. What about square root of 11? No, it's a prime number, so there isn't anything that you can multiply by it to be able to get 11 except for 1 times 11. So that's as simplified as those get, and because of the fact that they are not like terms, they're not like radicals, then that's it. That's your final answer right there. So let's write this down. If you've got different radicands, you must try to simplify first. If they are still different, then you cannot combine. So your final answer is just going to be 12 square root of 2 minus 4 square root of 11. That's as simplified as it can get. Okay, if your radicands are different, then you have to try and see if you can simplify those radicals down. Sometimes you can simplify them and it will create a like radicand. But if it doesn't, if you simplify it and they are still different, then that means that you cannot combine them. Okay, now it doesn't have to just be numbers or just variables that are like. You can have it where it's a combination of number and variable, and they still be a like radical. So for example, with number 4, we have negative 8 square root of 3x plus 6 square root of 2x plus 10 square root of 3x. So we do have some that are like radicals. We've got the square root of 3x. That happens to be a like radical. Square root of 2x is not. Square root of 2x is just going to be all on its own. So we're going to focus first on the negative 8 square root of 3x plus 10 square root of 3x. So I'm going to rewrite these so that they're side by side. When they're like radicals, I like them to be side by side. So negative 8 square root of 3x plus the 10 square root of 3x. And then what's not like is plus the 6 square root of 2x. That one is the one that's different. All right, so I'm going to focus on adding this negative 8 plus 10. What's negative 8 plus 10? 2. So we get 2 square root of 3x plus the 6 square root of 2x, and that's our final answer. Okay, it doesn't just have to be numbers or just variables. It could be a combination of number and variable that create a like term. All right, let's take a look at problem number 5. Square root of 12 and square root of 27. Are they like radicals? Yes or no? No. So the first thing that we need to do is try and simplify them. So let's go ahead and factor the 12 out. What is the largest perfect square that can divide into 12? 4. The largest perfect square that can divide into 12 is going to be the square root of 4. Okay, and then that would also leave us with the square root of 3. Plus, what about the 27? What's the largest perfect square that can go into 27? 9. So we have the square root of 9, and then that can break down to the square root of 3. Okay, so the square root of 4 is going to give us 2, so we'll have 2 square roots of 3 plus the square root of 9 is going to give us 3, so we have 3 square roots of 3. Do we now have like radicals? Yes, right? They both have a square root of 3, so we can combine those together. What is that going to give us? Very good. 5 square root of 3, because you do 2 plus the 3, that gives us 5, and then square root of 3 just stays as it is. Let's do number 6 together. We have 3 square root of 8 plus square root of 45. Again, those are not like radicals, so we first need to see if we can simplify it. Now this 3 is a coefficient that's going to hang out on the outside. That 3 is going to hang out on the outside, so I'm going to go ahead and bring it down already, that's just as it is. It's just a 3. But now we need to break up square root of 8. What's the largest perfect square that goes into 8? 4. So we have square root of 4 and square root of 2. Okay, let's go ahead and simplify square root of 4. What is the square root of 4? 2. So we now have 3 times 2, and that's the square root of 2. And what's 3 times 2? 6. So we have 6 square root of 2. Okay, so that was what we simplified. 3 square root of 8 in simplest form is 6 square root of 2. Let's go on with the 45. So we've got this plus sign that's going to be in between these the entire time. Square root of 45, largest perfect square, 9. So we get square root of 9 and square root of 5. What's the square root of 9? 3. So we have 3 square root of 5. All right, can we combine? No. Okay, so that is our simplest answer. That is our simplest answer. 6 square root of 2 plus 3 square root of 5. Sometimes you can't combine them at all. All right, I want you guys to go ahead and flip it on over to the back. I want you to try the problems there are on the back side. So if we're looking at problem number 7, we have square root of 2x minus the square root of 8x plus the square root of 32x. So we need to go ahead and simplify these to see if we can get anything that is of like terms. Can we simplify 2x? No, that's as simplified as it's going to get, so it's going to stay as it is. Is it a perfect square at all? No, there's nothing in here that's a perfect square, so it's just going to stay the square root of 2x. Then we've got our minus sign. Now the square root of 8x, can we break that down? Yeah. What is the perfect square that can come out of it? 4, the square root of 4. And then the non-perfect square is the square root of 2 and also the square root of x. So I can just put square root of 2x. I don't have to break them all apart. Okay, once you start getting used to how to break them up, you don't have to sit here and break them into little individual pieces only to put them back together. You know that square root of 2 is not perfect. You know that square root of x is not perfect, so just leave them under one house. Okay, square root of 4 is going to become a 2. So you have 2 square root of 2x. Okay, plus the square root of 32x. What perfect square can we take out of 32x? 16. Good. Square root of 16. And then we are left with the square root of 2x. Okay, square root of 16 can be simplified. We can simplify that to a 4. So we have 4 square root of 2x. Okay, so now here's my expression so far. I have square root of 2x minus 2 square root of 2x plus 4 square root of 2x. What do you think I should put in front of here? A 1. I need to know that I have a coefficient in front of there. If it's not written, I'm just going to put that little 1. And now I just focus on, they all have the same radicand, right? They all have a like radical, square root of 2x. So I can just do 1 minus 2 plus 4. What is 1 minus 2 plus 4? Try it again. 3. 1 minus 2. 1 minus 2 is a negative 1. A negative 1 plus 4 is a positive 3. You okay, Bridget? She's waving it off. I'm fine. Again, let me repeat that. 1 minus 2. Guys, what's 1 minus 2? Negative 1, right? You start with a positive and you're taking 2 away from it. It's going to bring you down to the negative. So you have negative 1. Negative 1 plus 4 is going to give you a positive 3. Okay? 1 plus 4. 1 plus 4 is 5, but then you still have that minus 2. That would be a 3. There's all sorts of ways that you can look at it. And then you're going to keep these square root of 2x's as they are. So you should have 3 square root of 2x. If you put 5 square root of 2x, and just out of curiosity, how many, because there seemed a lot of you who seemed confident with 5. How many of you put 5? Be honest, because there were several of you who said 5. Okay. What made you do that? I'm just curious. What made you think of 5? Oh, okay. So you did two, so you did the reverse. Okay. I can see that. I can see that being a mistake. So just be mindful of the order that you are subtracting. You good, Alex?
Yep.
Okay, then sit. All right, let's take a look at problem 8. Problem 8, we have 4 square root of 12xy plus the square root of 75xy. Okay, so again, we're going to just focus on them as one part at a time. I mean, if it makes it simpler for some of you, maybe if I just hide that part. Let me just hide that, and let's just focus on simplifying that. It's just one single problem that I'm simplifying. That 4 is going to come right on out into the front. It does not have any radical around it. It's just a 4. The square root of 12xy. Let's break the 12 up. How can I break the 12 up? Okay, square root of 4, and then square root of 3. Now, the x and the y, are those perfect? No, they're just single, so I can go ahead and just like Alex said, I can put it inside the same radical, 3xy. Because they are not perfect, they can belong under that same house. Okay, so now this 4 is still my coefficient. What is the square root of 4? 2. So we have 4 times 2, square root of 3xy. And then 4 times 2 is going to come out to 8. So we get 8, square root of 3xy. Okay, so I have simplified this single term all the way as far as it can go. 8 square root of 3xy. Now I'm going to hide that term and I'm going to focus on this one, this positive square root of 75xy. So let's focus on that. I know I'm going to have a whole bunch of plus signs in between here. Square root of 75. Let's break up 75. 75 can be broken up as the square root of 25. And the square root of 3. Again, those x and y's, since they are not perfect and they can't be simplified any further, they're just going to stay under the house. So they're square root of 3xy. Square root of 25, we can break that down into just a 5. So we have 5 square root of 3xy. All right, are they like radicals? Yes, they are like radicals. So we can go ahead and just add. We can do 8 plus the 5. What's 8 plus 5? 13. So you should have gotten 13 square root of 3xy. Alex is doing his little dance. All right, let's take a look at problem number 9. Again, don't look at it as an entire problem. Just look at it as little pieces at a time. Let's just focus on 9 square root of 75. 9 square root of 75. That 9 is going to come out into the front because it's already simplified. The square root of 75. How do I break square root of 75 down? What are the factors I'm going to focus on? 25 and 3. Square root of 25. Square root of 3. Okay, what is the square root of 25? 5. So we now have 9 times 5, square root of 3. And what is 9 times 5? 45. So we have 45, square root of 3. Okay, minus, let's focus here. We've got the 2. We're going to break square root of 27y up. What's the factors for 27? 9 and 3. You're going to notice, guys, that you're going to get the same kind of numbers over and over again. You might as well start memorizing what they are. So we have 9 and 3. Where does the y go? With the 3. The y is going to go with the 3. What is the square root of 9? 3. And what's 2 times 3? 6. So we have 6 square root of 3y. Are those the same? Why are they not the same? There's no y on the first one, right? This one is just a 3. This one is a 3y. So they are not like terms, so those cannot be combined. Let's focus on the last one. We have a plus square root of 48y. So we've got our plus. Let's break the square root of 48y up. What's the perfect squares that can go into it? 16, and then the 3. Where's the y go? With the 3. So we have square root of 16 and square root of 3y. Square root of 16 is going to give us a 4, and then we have that square root of 3y. All right, so the only ones that we can combine together are the ones that have the square root of 3y. So remember, this is a minus sign in front of it, isn't it? That is a minus sign in front of it, so we're going to focus on it as a negative 6 plus 4. A negative 6 plus 4. So this 45 square root of 3 is going to stay just as it is. And I'm going to keep it all in blue. So we have 45 square root of 3. And then what is negative 6 plus 4 going to give us? Negative 2. So we have negative 2 and then square root of 3y. There's your final answer. 45 square root of 3 minus 2 square root of 3y. Okay. This last one, it's a rectangle. A rectangle has a length measuring 5 square root of 2x plus 8 square root of 18. And it has a width that is measuring 2 square root of 48x minus 2 square root of 72. We want to know what is the perimeter of the rectangle. The perimeter. Okay, so when we've got a rectangle going on here, we have a length and a width. The length is 5 square root of 12x plus 8 square root of 18. The width is 2 square root of 48x minus 2 square root of 72. And then it's the same again on the bottom and on the side. Okay, so this is the same and this is the same. So that means we have 2 of these and 2 of these that we're combining together. So when I write my whole problem out, it's going to be 5 square root of 12x plus 8 square root of 18 plus 2 square root of 48x minus 2 square root of 72 plus all the same stuff again, right? Plus 5 square root of 12x plus 8 square root of 18 plus 2 square root of 48x minus 2 square root of 72. So if I just go ahead and combine all those together, I wrote them all on top and bottom so that way I could see that these line up, don't they? So I know all of these are right now like terms. What do you think 5 square root of 12x plus 5 square root of 12x is going to give me? 10. Not 24x. Remember, we don't change the radical. The radical stays as it is. So it's 10 square root of 12x. What about for here? This would be 16 square root of 18. Plus, this would be 4 square root of 48x. This would be minus 4 square root of 72. Right? The minus and the minus, when we combine them together, it's just a negative 4 square root of 72. So now we just have to focus on simplifying these out and then combining any like terms that we can. So let's focus here at the 10. We've got our 10 times, my 12 can be split up as square root of 4, square root of 3x, plus, we've got this 16 times, my square root of 18 can be split up as square root of 9, and square root of 2, plus, I've got this 4 times, my square root of 48x can be split up as the square root of 16, and square root of 3x, minus this 4 times, my 72 can be split up as the square root of 36. Oops, that should have been in pink, sorry, square root of 36. And square root of 2. Okay, so now let's go ahead and simplify all those square roots. So we have 10 times 2 square root of 3x plus 16 times 3 square root of 2. plus 4 times 4 square root of 3x minus 4 times 6 square root of 2. Okay, so let's multiply all these things that we can. We have 2 times the 10, that's going to give us 20. So it's 20 square root of 3x. Plus 16 times 3. 16 times 3 is going to give us 48. So we have 48 square root of 2. Plus 4 times 4 is 16. So we have 16 square root of 3x. And then minus 4 times 6, which is 24, square root of 2. I'm still not done, though, because I can combine like terms. I can combine this 20 square root of 3x plus this 16 square root of 3x. 20 plus 16 square root of 3x is going to give us 36 square root of 3x. Then we've got this 48 square root of 2 that can be combined with this negative 24 square root of 2. And that's going to come out to, what, 24, positive 24 square root of 2. And then you're done. That's your final answer. It's a long problem, I know. You won't have anything as difficult as this one. I just wanted to throw that in there and see if you could do it. Okay? Now, I think we're going to do a GIM kit. I did have a worksheet for you guys. I think I'll give that to you on Monday, though. Or I might load it into tonight or today and have you do it tomorrow as a quizzes. So we're going to do a GIM kit just to get you guys practicing.